don't worry, it's never gonna work on the first round. But yeah.
All right, let's
We'll
see.
eventually make it work. Yep.
So I'm just gonna. Oh, you want to introduce something, or should we
Sure.
just go on?
Yeah. No. Please. Just introduce your project and what's the goal. What's the
Oh,
next
okay,
step?
sure, yeah. So I'm trying to build a CNN with a X-ray data set, and we have X-rays of the chest, a lot of different pictures, and some of them are fine, so the person is healthy, and some of them, yeah, and in some of the pictures, the person has either virus or bacteria infection, and so now, yeah, we have 3,875
Yeah.
images where the person is sick and 1,341 where it's normal. So no sickness detected.
Okay.
And
Cool.
then we want to train this to be able to predict if an X-ray contains like a person, like an image of a person's chest that is normal or infected.
Man, that's so cool.
Yeah, contrary to other similar tasks, we have more images in the positive class and less images in the normal class. Usually, what we have is for
Hmm.
medical datasets, the data is usually skewed towards the normal class. You have more classes to more examples in the normal class and fewer examples in the abnormal class. Uh, but here the thing is the other way around, anyways. So you can also you can proceed to the next cell where we plot some of the images
Let's
And
to
see.
see how they look.
don't worry, Naveed. I mean, don't worry, Felix. We've all done this project, so we're all here to help you together. We're all here to debug it together.
Yeah, great. Nice. We have some images.
Wow.
Yeah. Unfortunately, this code doesn't print with it which are the normal ones and which are the
Yeah,
problematic
with the
ones.
cats and dogs, it's easy to see, right? But this
Yeah.
one is not that easy. Especially some of them, they have like an interesting, like a pacemaker or something, which is interesting as well.
hmm
So,
Some of the images are also grayscale. Maybe that's because the matplotlib gives it a its own color. Maybe all of them are
hmm.
grayscale.
When I looked at it, it was grayscale. When I looked at the
Oh,
individual images,
then that,
yeah.
then this is matplotlib is giving it its own color scheme.
Hmm.
Yeah.
All right. So
So
now we're kind of reformatting the images, or we did that already.
no. So here we are going to be
Yeah.
pre-processing them in the next cell. In this cell, we have the model, the CNN model that we are going to make use of. So the model is having one convolutional layer with 16 filters. Each filter is a 3 by 3. The input shape that it is expecting is 150 by 150 by 3.
Mm. Yeah, I didn't change anything here. This is from the template basically. I
Mhm.
guess maybe we can try to run it first and see if it's any good, and then otherwise we need to change it.
Yeah, we can then improve it later. But one thing that needs to be changed here is the color channel because you said I had grayscale, like the images are
Mm.
grayscale. So maybe that in the third dimension where you have three, it should be one.
Here.
No, in the input shape.
Mm. So
This is the shape of the images.
so before it was 3. That means what exactly? Like the bytes, the color depth basically.
Yeah, so that three simply means that we have the three color channels RGB,
Yeah.
which is what is the usual format of color images. But since in this case we have grayscale images, that's why that color channel is one instead of three.
Hmm. Yeah. All right.
And then the output layer stays the same because we are looking into binary classification problem. That's why we just have a single neuron with the sigmoid activation function, um, which would just spit out the probability of how much it thinks it belongs to class one, meaning positive class. And then you can threshold that probability to decide between if it's class one or class zero. Does it make sense?
The last part I didn't get. Thresholds.
Oh, so
Oh.
the model is actually going to give
Mm.
you a probability score,
Like,
which
yeah.
would vary between 0 and 1.
Mm-hmm.
So the closer it is to 1, it just simply means the higher the model thinks that this belongs to class 1. And the closer it is to 0 means the model predicts that there's little chance that this is class 1, meaning this is the other class. So because we would like to have labels at the end, we can then put a threshold, say zero point 0.5, where we say if the probability is greater than zero point 0.5, just make it class 1. And if the probability is
Okay.
lesser than zero point 0.5, just make it class 0.
Mm-hmm. And where do we do that?
In the last layer, in the last layer, you see the dense with a single
Mm.
neuron, and the activation function is sigmoid. So
Sigmoid.
remember
Mm.
the sigmoid activation function.
Yeah, it's like, yeah.
So that's what it is doing. It is going to squash the whatever is coming from the network between 0 and 1,
Mm-hmm.
which you can treat as a probability.
Okay, great. Cool. Then let's run this one.
Yep.
Okay.
Prefer using an input shape object as the first layer. It's throwing some warning. Maybe it's something related to TensorFlow, so we don't need to worry about it right now. I think it is requiring the input shape to be passed as an object, um, but you can ignore that for now.
Okay.
So here is the model summary. Um,
Mm.
Even with the single convolutional layer where we have 16 filters, it's the parameter, the total number of parameters that we have, uh, the number is huge, and it is going to take 21 MBs to store these number of parameters. For the convolutional layer, the parameters is just 160, but the fully connected layer, if you see most of the, or rather all of the parameters, trainable parameters come from that layer. And this is something that we discussed when we introduced CNNs. This is probably one of the drawbacks of using a fully connected layer directly instead of passing it through the convolutional filters. In that case, you would have to take every single pixel and connect it to the every single neuron in the fully connected layer. That's why they're called fully connected. Um, we can also skip these dense layers in our scene and
Mm.
architecture as well if we would have some, let's say, memory constraints or computational constraints. We can directly
Mm.
work with the just with the CNN layers as well. But since we don't have any such constraints here, we can proceed with this model.
Okay. Yeah.
So the model is just compiled with the Atom optimizer, and the
Mm-hmm.
loss is binary cross entropy because it's a binary classification problem. That's why we are making use of that logarithmic loss function, which we talked about in some earlier session. That function is called cross entropy, and we are using its binary version. So if we would be solving multi-class problem, then in that case, this loss would be categorical cross entropy. But since it's a binary problem, binary classification problem, that's why the loss is binary cross entropy.
All right.
And here is
Mhm.
where the pre-processing of the data comes. So as you can see, we're using an image data generator. This is an efficient way of handling imagery data in TensorFlow. So what they have is this data generator um, where you eh, where you have declared the image generator. You can specify some pre-processing steps. Right now, we are only rescaling it, meaning dividing every single picture with 255 to normalize the pixel intensity values.
Mm.
But you can also specify some other operations as well. So, for instance, if you'd like to do any image augmentation, augmentation is where you just simply take a picture and rotate it slightly or flip it horizontally in order to increase the amount of data that you need to train the model. So because neural networks are very data hungry, that's why usually data augmentation is used in order to increase the amount of data. So you can specify those steps in here as well. But for now, we're just simply making use of the rescale method where it would just simply divide every single pixel with 255. And then once you declare the generator, you then just simply specify to it where the data would be coming from. So here we are using the flow from directory, which means the data is coming from the directory, which we are going to specify to it. So as you can see, the trend directory, we passed it as an argument here,
Mm.
where our images are stored. And then we also specify the batch size, which means the images would be fetched in 16 chunks. Class mode binary just simply tells it that it's a binary classification problem. And then the target size is 150 by 150, which just simply means take every single image and resize it to this fixed shape.
Mhm.
Because if you don't do that, then some of the images might be of different shapes and that could be problematic for the model. So that's why we have to resize every single image to this fixed size. We do it for the training set. We also do it for the validation set. Um, so that's that.
Mhm. Okay, let's run this one.
Yep. So it says it found 5,216 images belonging to two classes for the first generator, which is a training generator, and then it found 16 images for the second generator, which is the validation generator.
I don't know if that's enough.
Yeah,
16.
it seems like small as compared to usually what we do is we set aside 20% of the training set for the test set, but for this particular
Mm.
Right. I thought
But
um,
didn't we? Mm.
this is something that the data is already split into, so we cannot do much about it here. What we can do is create another test set inside our training set. Um, that would require some
Mm.
work,
It's
not much,
only
but yeah. But
only
here
splitting.
they have provided it beforehand. So let's work with it, and then maybe later on we can create another split inside our training set.
Mm-hmm.
This one is going to take a while.
All right. I'll run it first. Oh.
Let's see. Oh, so it says that the images are not. Um, they have three color channels. So you can go back to the model and replace that one with three.
Where do you see this? Here. Mm.
Yep.
Here.
In the line below value error, so it says input shape to have value 1 but received input with shape 150 153. So even though the images are grayscale, still they have saved it in a
Mm.
format where it has three color channels. So
I
change
was
the
Okay.
model.
wondering about that because actually they don't. They look very colored to me.
Yeah, but James, sometimes, like, even though the images are grayscale, still,
Oh, that
yeah,
one.
they're saved in such a format where there's
Mm,
three color channels. You can also do something like take the image and like convert it to grayscale. That way, you won't have to change the model then.
Mm.
But the simpler way would be just to change the model here. Felix, you would have to run all the cells once again.
All the cells. This one too.
No, no, not that one. Yeah,
Yeah, I was gonna say.
this one.
Uh, okay. All right. Let's see. Okay, that looks better. Executing.
The first epoch usually takes longer. Maybe TensorFlow is having some internal settings, but still, the images that you have are you have 5,000 images, so it is
Mm.
going to take some while it trains.
Mm. Yeah. What I'm especially interested in, and why one reason why I chose this data set is because I'm curious. James last time showed us how to kind of output the um,
The
what the model
intermediate
sees.
filters. Yep.
Basically, this is like for his dog, and I would love to see like what it's looking at when it's detecting the disease. That might be
Yeah.
interesting.
Validation accuracy is 81. Training accuracy is 92. Maybe Burhan can present his project uh, till this training finishes. What do you think,
Sure.
James?
yeah, that would be great.
All right, then
Perfect.
I'll stop my screen sharing.
Hello, Burhan.
Hello, James. How has your day been so far?
My day's been about 20 minutes so far.
I mean, still something, right?
I mean,
Anyways.
it couldn't start any better than that.
hmm So, yeah, this was basically the data set I used was about emotions. Uh, we would actually find out the different classes that we use later. So we got obviously the libraries at first, and then the data set is actually named sentiment images classifier. So it actually tells you if the goal was to give the model an image, and then using that image, it will either predict if the person is happy, sad, or I guess we have like six other emotions. So we'll just have a look. So we
Text a little
unzipped
bigger.
it,
Make the text a little
and
bigger.
wait, do you want me to zoom?
Yeah, just make the text a little bigger. Yeah,
Wait, is that
that's
okay?
better.
And then I was just checking the directories that we have, and the emotions that we have is like one's fear, the other one's disgust, happy, pain, sad, and anger. So total of six emotions. And then we define directories for each category. So all of the data is in the base directory, right? So we have like 163 images for fear, and 201 for disgust, 230 for happy, pain is 168, sad is 224, and then anger is 214. So the most amount of pictures we have is for the happy data set, and we're gonna use all of these images to train the model, right? So far, I hope that makes sense, right?
Yep.
Yep.
Okay, perfect. So now we're defining the model. So as this is a sequential model, we're actually building the layers, and the layers we're using like 32 neurons here. And then I moved it up to 64, and then we have 128. So the input shape is minimized to this dimensions with this color code, and this is what the three layers look like for now. And then we actually downscaled by using flatten to not put much load on the computational power. And yeah,
Yeah,
that's about.
Burhan,
Hmm.
can you scroll up to the model? Yeah, just right here for a second. So,
Sure.
Felix, if you could see, previously we just simply used a single convolutional layer with
Mm-hmm.
16 with 16 filters. Now, as you can see, Burhan is so like, how can you further maybe make this model more complicated so that it can work for some more complicated problem you're looking into. So simple ways to just take multiple convolutional layers on top of each other. So as you can see, he's using first convolutional layer with 32 filters. Um, the filter size is 3 by 3. Activation ReLU, which stays the same throughout, and the input shape is the shape of the images, and then he's uh, max pooling it. So if you remember, we just simply take 4 pixels and replace them with the maximum one. That's what the max pooling is doing. And then another convolutional filter, convolutional layer with 62 filters, 64 filters, activation function ReLU, and 3 by 3 is the size. You can change the size of the filters as well. Um, and you can also of course experiment with the activation function, but most of the time you'd see a ReLU there. And then another convolutional layer with 128 filters. um, and once he extracts features using filters, he then flattens them into one single long vector, and then he feeds that into the fully connected layer. Can you scroll down a little bit, Burhan?
Sure. Is that all right?
So yeah, so there's a dense layer with 512 neurons, activation function ReLU. And then finally, since it's a multi-class problem now, he has more than 2 classes. That's why the number of neurons that you see, he has put a function, length function on the categories. So let's say you have a total of, I think he has 6 categories. So length of categories would just simply return that number of categories that you have, which is 6. And then the activation function he's using. So for your problem, since it was a binary classification problem, we used the sigmoid activation function, which just squashes um, the input, the output between 0 and 1. But here, since we have more than 2 classes, that's why we are making use of an activation function called softmax. So what the softmax would be doing, if you remember the discussions from the last time, it would just um, the model would be predicting probabilities for every single class, and the condition would be that if you add all of the probabilities, it should sum up to 1. So let's say for the happy category, it spreads a probability of zero point 0.5, and then for the rest of the categories, the probability would be distributed in such a way where if you sum them all together, it would be 1. Um, and then, as you'll see, as Burhan proceeds through the code, he would be then to decide which class the model is predicting, he would be just picking the probability which is maximum, and that would be the decision of the model. So you'll see that next. Burhan, you can proceed.
Sure. So after doing that, I was compiling the model, and then I used this. I was using Atom for as the optimizer function, and then we have for the loss function we got sparse categorical cross entropy. The reason we used this was because the labels were not one hot encoded. It was actually integer labels for each of the categories, so that's why we use sparse categorical cross entropy. And this is about the compilation of the model, and here we're actually rescaling the images into this format so that every image is in the same format to be passed. And that's what we did here. After after doing this, we got the train and test data gen, and we passed it through the model, and then we got train generator, and then we got the validation generator. So this is for both of these, and the class mode we're using is sparse because we have multiple categories here. And this is about it for the data generators, both training and validation generator. And then we're actually training the model here, which is I actually use 15 epochs for this model. because it usually takes a lot more time because it's just images, and I actually got pretty good results. So the reason you guys see really good accuracy right away is because I was training the model existing on the same data before. So it's not actually 15, but it has to be around 20 because I used five or six before. So this is why you guys see the jump to be this straightforward.
Yeah,
And
so when you
after
call
doing
the
that,
model dot
yeah,
fit function, TensorFlow retains the weights it has already trained from the previous
Oh,
epochs.
yes,
So that's
yeah,
why when he's running the model, the accuracy is already at 97, 99.
yeah. Wait,
sick.
I actually used like I used like 20, 30 bucks before, so I don't really remember, but this is not just 15, just so you know.
Yeah, but if
So
you would have disconnected the runtime and
yeah, yeah,
then you would
yeah,
have run it, would have
yeah,
started training from fresh
true.
weights, which would be random weights, and then the accuracy wouldn't be that much high.
Yep. So after doing that, we actually evaluated the model. We got accuracy of 99.7%, and I think that's pretty much pretty good accuracy, right? I hope you guys agree with that. And then we're just
Yeah,
testing out the model. So uh, yeah. So we got Drake's happy picture, which I'm sure you guys agree with the picture being happy, right? So
yep,
uh,
Yeah,
so we just passed this picture through the model, and we got the prediction to be happy. So this is one image, and then we have another image, which is this one. What do you, we previously actually I asked Naveed and James to guess what
let let
emotion.
let, let Felix guess if this
Yeah,
is
Felix,
sad
you can
or
guess this time. So Felix, what do you think? What emotion do you sense here?
I guess it's sad. Yeah.
Okay, so we actually passed
Okay.
that, and we got fear for
Fear.
this
Okay.
index. Yeah. Also, a bit about the probabilities. So we got six subclasses, right? Anger, disgust, fear, happy, pain, and sad. And these are the probabilities of it being either one of these six. And if you actually sum all of these values, you will get around one. So that's what I did to Naveed was actually teaching us about this, the predictions. And if you
Mm.
actually sum all of these values, you get one as the sum, right? And whichever one of these is like the highest value, the model will actually choose that. In this case, it was fear, which was this one, and this is probably the highest one out of all of the other five, right? So this is why we
yeah.
got
So
fear here.
Felix, if you look at the line where he's using the np dot argmax uh, from the prediction, so what he's doing, he's passing the image to the predict function. The model is having predictions. Since we have six classes, you get probabilities for every single class. Softmax makes sure that these are probabilities, so that if you sum them all together, it gives you one. And then in the next line, in the RMX line, he's just simply picking the index of the probability, which is maximum, which means it belongs, like the model, the highest confidence of the model is that this example comes from that particular class. So he's then picking the class name according to the maximum probability index. And
and
then he's
Hmm.
printing that class as an output decision of the model.
this one is really interesting because the highest probability is 49%.
Yeah,
Yeah.
So
So so the model, so 50, almost 50% the model thinks it is what, which class
fear.
it is. It's
Isn't it
fear.
sad?
but
Mm.
I actually asked the chat, and the chat, we had two suggestions from the chat. One said bored, is it bored, and the other one said fear. It's fear of another diss.
Oh damn. That's actually fair because it is fair.
So, what was
So
the image labeled as? Was it correct? Is it like labeled as fear or?
What's the correct label for
no,
this? Oh,
wait. This is the image that I randomly chose, so we don't
Uh,
know
oh,
for sure. So
You gotta ask him.
yeah, this is not part of the model, the training set.
okay.
Yeah, yeah. We'll have to ask Rick. Anyways, so we got one last image. So this is actually goofy, but what do you think this emotion is?
Looks angry to me.
Okay. We actually got anger, so you were right on spot. So yeah, that's pretty much it about this model. I hope that makes sense.
Yeah,
We
excellent
yeah
example
yeah
of
we got the sum as one again. So yeah, that's pretty
excellent
much it.
example of excellent example of a CNN use case.
Thank you.
I have a question. So when you pre-process those images, why you have this like X and Y axis? Is that something that you ask for in the pre-processing?
What are you talking about?
So in the images that Burhan just showed, there was this X and Y axis, like kind of framing the image.
Oh, that's because Matplotlib introduces those. You can turn them off. The
Okay.
axes. So I mean,
So it's not fed into the model. It's applied after.
no, yeah, this something comes from the Matplotlib.
Right. Okay.
How's your
Cool.
model looking, Felix?
It's in the 15th epoch right now.
Oh, it's still going.
Yeah.
Burhan, you can also add the code for printing what is called the classification report, where it tells you, but the model is not currently running, so we won't be able to do that. But um, once you have a prediction from your test data set, you can then construct what is called the classification report, where it computes the accuracy, the overall accuracy of the model. It also computes the metrics such as precision, recall, and F1 score, which actually is a evaluation metric which is computed for binary cases. So, for instance, if you would be computing the precision for the fair class, it would treat the fair class as positive class and the rest of the classes as the negative class. And then it computes how much the model was capable in recognizing the fear emotion, and how, so you can do the same analysis for the rest of them. And you can also construct what is called confusion metrics, where it tells you what classes the model was confusing for other classes, and which classes was it correctly identifying. So classification report and confusion metrics are the two most widely used evaluation metrics with classification tasks.
Felix, how many
Yeah, let me
epochs?
see if I can get it running. If not, then we can use that on Felix's model.
It's
Yep.
I think it's done. It's 15 out of 15. Now it's done. Yeah. Just now. Do you want me to share my screen again?
Yep.
Okay, let's see. Can you see this? Yeah, so we ran the model training and we have 15 epochs, 15 out of 15. And I don't know if this is true, but the accuracy seems to be 100%.
100%. Yeah.
It is true, but the model is getting 100% accuracy on the training set. If you
Mhm.
look at the validation set, accuracy fluctuates a lot.
Yeah.
That's usually the case when you have fewer examples um, in your data. For the test set, we just had 14 or 16 images. That's why.
Yeah.
But yeah, you can proceed with the rest of the code. Evaluate the model to see. Yep. So the first one is the loss of the model, and second one is accuracy, which is 0.87, meaning 87%.
Mhm. How much
And
did you
then
have here, Burhan, in this
Yeah,
validation set accuracy?
I had 98%.
Nice.
Interesting.
Okay. All right, so that makes sense. So then,
Yeah,
sorry.
unfortunately, we won't have any example images for this particular data set because it's a medical data set. Otherwise, you would be able to test the model on random images. And even if we get an
No,
image, we won't know what the true level is.
so I found like there is a test data set as well. So we use the train and the validation set, right? So far. And then there is a test data set, and I put one
Oh,
of those in here.
mm-hmm.
So maybe we can try that one.
We surely can try that.
Um, all right, so okay, I didn't try this one yet, but let's
This will
see.
give you an error because the file is not here in the collab directory. So wherever the file is, you need to bring it to the current directory. Where
I
is this
think
file stored?
it is, yeah.
Okay, so you just have to copy that path and paste it inside the load image method.
Yeah. So where
Oh,
that?
in here.
Yeah.
Yep.
Yeah. All right, let's try again.
Normal.
Okay, that's wrong. This is virus infection.
Oh,
Wait. Yeah. Okay. It kind of looks like pneumonia. Is that what you're saying?
Yeah, and I know it's a virus infection because that's the picture I picked.
Oh. Okay. Yeah. You can kind of see something that funny going on there.
Yeah.
Felix, can you separately print this line model.predict with the image we shaped so that we can see what is the probability score it is assigning to it?
Okay. Where do I do that?
In the line where the model is doing prediction, model.predict.
Mm-hmm. So wait, it's not here, right?
In that line,
Model.predict. Uh-huh.
you just copy the model.predict
Mm-hmm. Oops. Yeah. And then
and run it in a separate cell, including
okay.
that image. You have to pass the image.
Wait, so including that
Cr-
image. Mm-hmm.
Create a new cell.
Down here.
Yep. And yeah, now the parentheses and inside it the image we shaped.
Wait.
Oh no,
Like
you can
this.
just you can just literally copy paste it from here.
Yeah.
You don't
And run
have to
this.
include the outside parentheses.
Okay. And just
Yeah,
run this separately.
run this. Wow, the model is giving a probability of 1.
That's not a
There,
good model.
that is surely not a good model.
Can there be something wrong here?
There's,
It shouldn't be
uh,
exactly one, right?
it can be. Um, I think there's nothing wrong with the way this is implemented, but the way the model is trained, given the simplicity of the model,
Oh.
with the complexity of the task, maybe that could be the reason why this is
Hmm.
way off than what the true output should be.
What I don't understand is that the in the training set it predicted 100% accurately, and even in the other set it's 87%, which is not bad, right? I think above 70% is like
Yeah.
there's some signal, right? At least in the noise.
Can you try this on a different example maybe?
Yeah, sure. Let me see. Let's try this one. Give me a second.
What are you changing now?
Me? I'm uploading a new image.
Okay. Yeah.
So we have a new one, 174. I need to probably do that one right here as well.
Wrong again?
Yeah, I mean, what would you say?
Yeah.
This
Felix,
time it's
it's your job to make the prediction of the model accurate by including more layers, making the
yeah,
model more sophisticated.
But the model was 79% accurate, right?
even 87, I think.
87% accurate. Well, they
It
only gave
was
15 validation, or like 15 or 16 validation images, right?
Yeah.
Yeah, the test set here is not a very reliable one, so you cannot count too much on that. Um, and this is a typical case of model getting highly overfitted to the training set because you literally see 100% accuracy on the.
Yeah. Maybe this
Um,
already gives it away, right? If it's 100% after only like
yeah,
a half of the training.
yeah. Can you scroll up to the model again?
But the model is
Binary
here.
cross entropy. Binary sigmoid. Everything seems correct here.
Yeah. I mean, I can try again later
Felix,
to
how many of each type of image do you have?
I think it was like yeah, it was a lot of
Oh, really? A lot of pneumonia.
pneumonia cases, and then normal was 1,300.
Interesting.
And can you scroll to the class names where we printed the class names? Which one is it treating the class 1 and which one is it treating the class 0? It was down in the code.
Huh?
Yeah,
Where
where
is it?
we were making predictions.
Mm,
Down.
oh, you mean
Yeah,
here?
so here it means the normal is class 0 and pneumonia is class 1. And here it is predicting normal, meaning the model is predicting. That is kind of confusing
It's normal.
because the probability the model is fitting is 1.
So yeah, where is it that it outputs the probability? Uh,
Here, apparently.
image
Can you
reach, image
run
reach.
it again?
This one?
Yep.
Uh,
This is strange. I mean, getting a 1
this should be above.
is can't spot 1 right now. Let's see. Felix, you can share this code with me. I would also have
Yeah.
a look and see.
Yeah, I think one thing that I would want to do is also increase the size of the validation set. I mean, we have a lot of the test images, so we could just shift some over to the validation set,
Hmm.
right, to
Yep.
make it larger.
Yeah, you can do that inside this TensorFlow data generator where you specify the test ratio, and then
Mm.
you can make use of the same data generator by just varying what split you are talking about. You can chat GPT this thing, it would give you the code for how to create the test and try and split inside the TensorFlow data generator.
All right. Well, at least we tried.
It
Yeah,
would get better.
unfortunately, that one's not gonna work for the doctors. They're not gonna be able to use this one yet.
Doctors have to wait.
No, you're fine.
Model says you're good. um, yes, someone
Pneumonia
said.
is pneumonia is still kind of not okay, but imagine this for cancer. So you're telling someone you're normal,
So
and
the output was one, and that was the second class, and the second class is supposed to be normal, right?
it is supposed to be pneumonia.
Yeah, it was supposed to be pneumonia.
Yeah, because the
The
normal class was at the zero index, pneumonia was at index one. So it means the model was not saying you're normal.
wait, so
Why was it printing normal? Actually, Felix, the code that you're using for the prediction, it's making use of the np.argmax, which is not correct.
can we look back at the code again?
Yeah.
Yep, that is not correct. You'd have to use a
This one here.
threshold. Yep, because the argmax works for cases where you have more than one class and where you have used the softmax because it then picks the index of the highest probability. But even if you fix this now, the model is still not model is still dumb because it is the probability it is giving us is also one. Do you see the problem?
Mm.
Look at
Can
the.
you
Oh yeah, go
uh,
on.
can
But
you show me where do we specify which is one and which is like class one and class zero basically?
it is
Is it
actually the generator is picking that on itself. So you know that information from where you are making the predictions. Can you scroll down to where you're doing predictions?
Scroll down to where it lists the class names one more time. So we have
Here.
zero is normal and one is pneumonia.
Yep.
oh, so the first one is zero, the second one is
So,
one.
Yeah, so here the model is predicting this to be pneumonia. Uh, because of the np.argmax, it is saying it's normal, but that's not correct. Because
Ah,
the model is
okay.
saying the probability is 1, meaning that this is class 1. And class 1 is pneumonia. Remember?
So
So that's
actually
why.
it is working then.
Ah,
right.
yeah, it is working.
So,
Why won't I
so
think
what? How
about
do
this?
we need to change this one?
Can you
Okay,
print? Can you print just the output of model.predict?
it is 1.
Yeah, then it's working.
It's working. And
This is something.
Felix, do you also have examples from normal class?
Yeah.
Try that one.
All right. Give me a second.
It's funny.
But so how can we know that? How can we change the what you mentioned here so that it's actually correctly printing the
Okay,
class?
so what you need to do here is when you're doing model.predict, you need to remove the np.argmax from it and put a threshold there by specifying greater or equal to, let's say, zero point 0.5. So that way, if the probability of the model is greater than zero point 0.5, it would return a 1. If it is less than zero point 0.5, it will return 0.
Oh,
Mhm.
I think I know. I think I get it now. So model.predict always returns an array with one value in it,
Yeah,
right? So
which is
there's
probability.
the only index is going to be zero. So
Yep,
it's always going to return the first class.
yep.
Ah, didn't see that coming.
Did you upload the normal one?
Yeah.
try it
But
on it.
it's gonna be 1 too, right? I guess.
Yeah, but you need to run the cell below it where it says the model or predict. We will know it from the probability here. Oh, you need to specify it with the image.
Image reshaped.
Yeah.
Yeah. Oh, this is the normal image,
Yep.
but it still thinks it's ammonia because the probability is 0.9999.
Can we change
And
this
and and
NPR
the,
max somehow?
yeah, we can change that. Let me give you a reason for why the model could be giving you a probability of always one. So the data set that we have is skewed towards the pneumonia class because we had more
Yeah.
two times more examples in the pneumonia one than in the
Hmm.
normal one. And when you have more examples in one class as compared to the other class, the model gets to see more of those examples. So it is better in recognizing that class, but it is not very good at recognizing the other class, which it has seen lower number of examples.
Hmm.
And that's why, I mean, that could be a reason why the model is predicting that it is pneumonia every single time. But it's not the only. It's not the only explanation. Uh, of course, we still have 1,000 images in pneumonia in the normal class, so it should be able to recognize that class as well. Um, that we can put on the model itself. I mean, if we make the model more sophisticated, that way it would be better to then recognize the normal class as well. But at least some of the explanation comes from the skewed dataset as well. And to change this, Felix, you need to remove the np.argmax,
Mm-hmm. Mm-hmm.
and you can also get rid of the parentheses that comes with it.
Okay.
Not the square bracket, the parentheses,
You mean the blue ones
the blue
here?
ones.
Okay.
Yeah. And now write greater or equal to
In front.
in wherever the cursor was previously. Not there, because you have to put,
Okay. Like
yeah,
here.
yep, and equal to,
Like this.
yep, now 0.5, 0.5. Can you run it?
Mm-hmm.
Yeah, it returns a logical array, so you'd need to convert this to a value able to index the class name.
Yeah.
So you can convert it to a value by maybe calling np dot array on it and then specifying, or you can also write int function on it, which would convert it to 0 or 1, right, James?
Yeah, I was gonna guess to put afterwards a zero in square brackets, but I don't know if that would be the right way to do it. To call out the first
Uh,
value.
can you maybe check the whatever is inside the square brackets and create a new cell and paste it there?
Oh
Just
yeah,
this
that's
part
a good idea. Yeah.
Yep.
below.
Create a new Yep.
Like just here. We can just put it here.
Run it now. True. And now can you call the function int on it? So write int and put whatever is inside. I mean, put all of it
The whole thing.
inside parentheses.
Yeah.
Before.
Yeah.
Int and parentheses.
Yeah.
Run it now. Maybe
Works.
now it would work. You need to copy it entirely and paste it in place of whatever was set there previously.
Here.
Yep, just paste it.
Within the
Square
brackets, right?
brackets.
Yeah.
Run it now. Prediction of classifier is
Pneumonia,
Yeah.
where
No.
is it saying that?
which is wrong.
Wait, this one is normal.
Yeah, this one's normal,
Um.
apparently.
That's because the probability of the model is 0.9999.
Wait. So the
That's it.
first
It
class was n- normal, and the second class was pneumonia, right?
Yep.
And it's 0.9, so that means it should be pneumonia, right?
Yep.
So you're saying this
Not.
is this is a normal image?
Yep.
This is from the normal data set. Yeah.
Okay. So now we're at the opposite problem that we had before, but we
Yeah.
but we think this is actually comes to the yeah.
So if we
Chat.
now take the actual pneumonia image, then it should actually return normal, right? If it's working.
Now we all have pneumonia. Comment says.
Oh, okay.
Yeah.
Don't worry, brother. We are fixing it.
Oh, it's a person.
Yeah,
What am I
one of
doing?
the person says, does adjusting the threshold fix it? Problem is the model is already making the probability so close to 1 that if you put the threshold even at 0.7 or zero point 0.8 doesn't help.
We have a biased model then.
It's a highly biased model towards the pneumonia class, and we can fix this by making the model more clever, and also we can treat the skewed classes problem by maybe removing some of the examples from the skewed from the pneumonia class, or other way would be to increase the number of classes in the normal class. So one way to do it would be to maybe augment the data there. Um,
Hmm.
but this could be an exercise uh, which would be fruitful to do.
Okay. Cool. Um. Well, great work, Felix. I'm glad that we got it working in the end. Um, really
More or
impressive
less.
project to both of you guys, Burhan as well. Burhan, did you have any other thoughts or questions from all of that?
No,
Any
no.
closing?
I'm actually curious about the problem that we're facing. If it's pneumonia or not, but I think we can figure it out later.
Yeah, I'll share the notebook as well, the code.
Yeah,
Okay.
please do.
Great. Maybe it looks like everyone's leaving the library.
Yeah, library closes at 9. It's 7 right now, but at this time usually it starts getting empty.
Okay. Cool.
But yeah, just like Brahan said, we'll fix this issue. Felix, if you could share the code and also the data set, because I won't have access to it. So maybe you can upload it to your G Drive and make it public, that way I'll be able to access it, and I'll work on it.
We had a couple more questions from the chat. One said, for CNN and images, is there a sweet spot for neuron numbers and layers?
So the sweet spot comes from experimentation. There's no like one size fits all solution. So you'll have to experiment with different numbers for every single problem.
Okay. And then another question was, could we solve the bias by doing undersampling for the majority class?
Yeah, that is something that you could do. Usually, I mean, it's not a very good way to do it, but if suppose you have like lots of examples, let's say 10,000 images in one class and maybe 15,000 images in the second class, you can throw some of the information from the majority class. But the problem that we are looking into right now, like we have so few examples, that if you start throwing the information, it won't be a very fruitful way to do it. So maybe the way to go about it would be to oversample the minority class instead of undersample the majority class. How can we do that? One way to do it is to use traditional techniques like just simply rotating the images, adding some noise to it. But thanks to the generative models, we can also synthetically generate some of the examples from the minority class.
Exactly. Cool. Well, thanks guys for watching.
All right, I'll see you then.
Yeah.
Goodbye.
Thank you.
Thanks everyone. See you next time.
See ya.